All right, everybody, till now we have seen the range of the IP addresses where it starts from 0.0.0.0 and reaches up to 255.255.255.255. For the management purpose, we have divided this range into 5 sections, and these are known as classes: class A, B, C, D, and E. For the class E, this is for experimental purpose. We don't use it. For class D, it is used for multicasting purpose, and we use class A, B, and C for our regular networks. Let me tell you the ranges for these classes. For the class A, the address starts from 1 and it reaches up to 127 for first octet. For class B, this is 128 to 191. For class C, this is 192 to 223. And for class D, we have 224 to 239. Class E is for 240 to 255 range we have. But since I said we use only class A, B, and C, let's focus on these. Now, still, I see that there are a lot of IP addresses we have in this range for class A, B, and C. It means we still need a little bit more management stuff to manage these ranges for networks. So we have something to arrange them in a network, and that is called subnet mask. So we have default subnet mask for each class that is defined by IANA, or I say IANA. And here, these are for class A, we use 255.0.0.0. For class B, we use 255.255.0.0. And for class C, we use subnet mask that is 255.255.255.0. Now you might be thinking, what is 255 here and what is 0 here? Where you see 255, that defines the network part, and the 0 defines the host part. Let's take an example to understand it. Let's say there is a PC and it has an IP address 192.168.1.10 and subnet mask 255.255.255.0. What does it mean? Look at the 255 here. There are 3 octets, 3 sections which are using 255.255.255. So it means that it has a network 192.168.1, and this is the 10th host or 10th device for that network. Let's take another example. This computer has 192.168.1.150 and 255.255.255.0 address. What does it mean again? It means that this is 192.168.1's 150th device in the network. All right. So for the class C, for the given example, if I give you idea on the line, so it starts from 192.168.1.0 for this particular network, and it ends up at 192.168.1.255, because after that, if you add one more address into this one, the network will change and it will become 192.168.2.0, which will be the different network. The first IP address and the last IP addresses, first and last, these two IP addresses we do not use for any device. These have a specific purpose, and these are known as network address and the broadcast address. So the address which we can assign to any device from this network will start from 192.168.1.1 and it will reach up to 192.168.1.254. What does it mean again? If you take these two PCs and you connect using a layer 2 device here, which is a switch, these devices will not have any problem in communicating each other. So you do not need any router for communication since they are sharing the same network ID. They belong to same network. One more time, if I talk about this class C range, what I'm talking. So you might be thinking, can we further divide this network since these IP addresses are so much? Maybe we need less IP addresses in small networks. Can we do that? Yes, that is possible. You can break this network into different sub networks. For example, if this is the network line for this particular network, and here if you check the IP addresses, they are starting from 0 to 255, it means we have total 256 IP addresses. And if you divide this into two parts, each part or each subnet will have 128 addresses in this case. It means their addresses will be definitely separated. The first subnet will start from 192.168.1.0 and it will go up to 127. And the second subnet will start from 128 and it will go up to 255 here, right? And the remaining IP addresses in between we can assign to these computers. This process, as I said, this is known as subnetting. So two IP addresses we took for example here, and in this case, the first IP address 192.168.1.10, it will belong to the first subnet and 150 will go to the second subnet. Now, because this time they have different network, they will not be able to communicate to each other directly. They will need a router for the communication. Now the question comes here, what is the role of the subnet mask in this entire process, which is subnetting? So we will take a look onto this one. Stay with me.